All right, we're ready to start on number 3G on the bottom of page 3 in our 6.5 notes, and then we'll move on to the last page. So this one you can see is a little bit uglier, not bad, a little bit. Our calculator, so we can use that. Okay, this is going to be a FOIL problem again because we have 2 terms by 2 terms. So first we have 1/2 times 1/2. I think we can do that without a calculator, don't you? So 1 times 1 is 1, 2 times 2 is 4, so that would be 1/4 when we multiply our outer numbers. And when we multiply what's under the radical, we get square root of x squared. From outer, I think we can probably do this one too. 1/2 times 2/3, we'll do the sign in a second, just work on the numbers, is 2/6, right? Which is 1/3. And if you don't want to do it by hand, you don't have to, but just doing it, I think we should practice our arithmetic skills. So 1/4 square root x squared. From outer, we get a positive times a negative, which is negative 2/6, which we said simplifies to 1/3 because you divide both of them by 2. So negative 1/3 square root x y. And then from the inner, we get positive, so let's put our sign down, 2/6, which we said is 1/3 square root xy. And remember, this is a great check of your work because you look at this and you say, oh, these are conjugates. If I'm doing it right, the middle term should cancel. Do they? Yes. 1/3 minus 1/3 is 0. And then from L, positive times a negative, so figure out your sign first, put minus, and then we multiply 2 times 2 is 4 over 3 times 3 is 9, so 4/9 square root of y squared. So we just have 2 terms to simplify there. Notice they're both 2 of something, so they're going to come out. 2 x's come out as a single x, 2 y's come out as a single y. So that leaves us with an answer of 1/4 x minus 4/9 y. No radicals, as promised. Anytime you multiply conjugates, you will not get any radicals if you've done it correctly. And these were conjugates. Notice they're identical, except for one's a plus and one's a minus. Okay, let's move on to our last page, page 4 for section 6.5. So what happens, and you explore this a lot more in 150. This looks like problems we have on our test here, so that's why I like to do them, because it gives us practice for our test. But ones like this that are a little bit busier, you'll do a lot of those in 150. So yes, you should be able to know how to do this kind. This kind, well, I'm introducing you to it. You'll see it, but like I said, you'll get more exposure to it in the next class. So what do we do when we want to multiply radicals, but they don't have the same index? Remember how we said they have to have the same index? Well, there's still a way to do it. What we have to do is change them into fractional exponents. Remember doing that on the very, first or second section of this chapter. So we put powers here if there's not a power. So this is x to the 1/3 times x to the 3 over 4. Remember, the power goes in the numerator and the index goes in the denominator. And we did this problem, I can't remember what section it was, but it was in our notes. So in multiplication, when the bases are the same, we keep the base. And remember how I said you needed to write this step for your test in order to get credit? So show what the property is. In multiplication, we add our exponents. So this one I need to practice with you on the calculator because it's not going to give you exactly what you need. So, I think I'm going to go over here where the light's not so bad. Okay, so in the calculator, we're going to do 1. Oops, turn on the calculator, Norris. 1/3 plus 3/4. And we get 1 and 1/12. Well, have you ever seen an exponent that's a mixed number? No. So do you all remember how to make it into an improper fraction? I have my calculator magnified here, so you should be able to look at it and see it real fast. Look at right up here, this blue. A, B over C, 2, D over E. That means change a mixed number to an improper fraction. So hit second and the fraction key and enter, and there's our 13/12. Then we have to change it back to radical form. So that step was left out here. So let's go ahead and put that step in. So, whoops, this is what I wanted to circle, not that. So this is the 12th root of x to the 13th. So the index is always the denominator, and then you put this underneath, x to the 13th. So 13 is not divisible by 12, but we learned how in previous sections how to make it divisible by 12, right? We put 12 x's and then 1 x. Remember doing that? So now we have one of the numbers divisible by 12, and we haven't changed its value because 12 plus 1 is still 13. We just made it so now we can take this out. 12 divided by 12 is x to the first, so 12 x's come out as a single x, and then we have 1 x underneath, so 12th root of x, which is what they wrote right there, or what I wrote right there. Okay. So multiplying radicals with a different index, change them to rational exponents. That means fractional exponents, and then use your exponent rules in multiplication. Add the exponents, type it in your calculator. You get this using second fraction bar if it's improper, and then break it down. So turn it back into a radical and break it down. So I think I'm going to skip this section because this is just extra stuff you don't need to know yet. So we can do these two, and we'll save these two for Math 150. So let's go ahead and do 4A and B. And we'll just cross these out. I didn't do these I didn't do any of this page in my Math 121 classes. So you'll getting a little bit more knowledge than they are. So first step, just like above, remember we change them into fractional exponents. So we're going to do that here. So this would be a to the what? 1 over 2, right? So a to the 1/2 times a to the 3 over 4. And like I said, I put this problem on the test, so you will see this problem. So this is one you want to make sure you know how to do. So in multiplication, we keep the base the same, and we add our exponents. So 1/2 plus 3/4. So then you can go to your calculator. 1 fraction bar 2 plus 3 fraction bar 4. Oops, there's that mixed number again. We don't want that. So remember, we hit second fraction, and it says 5/4. So again, you need to change it back to radical form and see if it can be simplified. So the denominator becomes the index, and then we have a to the 5th. So remember, anytime your power is greater than your index, that means it can be simplified. So 5 is not divisible by 4, but can't we change it into 4 plus 1? So we can rewrite it as 4th root of a to the 4th times a to the 1st. So that's still a to the 5th, but now that allows me to take out this perfect 4th power. So 4 divided by 4 is a to the 1st on the outside, and then we get 4th root a to the 1st. So a, 4th root a will be our answer. Okay, now would be a good time for you to turn off your video and try B on your own before you watch me go through it. Okay, so we learned first you write them as fractional exponents. So because we have two things multiplied in there, those are called two factors. We do need parentheses. So 2x doesn't have a power, so we can assume it's 1 over, and the index is 5, times 2x to the power over index, so that'd be 4/3. So our bases are the same. Whenever our bases are the same, and you still need to keep the 2x there, because without you need to keep the 2x in parentheses, because without parentheses, that only puts the x under the radical, but they're both under the radical. That's why we need the parentheses. So this would be 1/5 plus 4/3. So again, we go to our calculator. And we type in 1 fraction bar 5 plus 4 fraction bar 3. And we get 1 8/15. Again, we don't want that, so we do second fraction, 23/15. So this is 2x to the 23/15. So now we need to change it back to radical form. So 15th root of 2x to the 23rd. So notice how the power is higher than the index. Remember, we can't have that. So we need to break it down into the 15th root of, we can get 15 out of there. So let's do 15 out of there because we need numbers that are divisible by 15. And then if you had 23 and you took 15 away, that leaves you with 8. So this is a perfect power. So 15 divided by 15, these 15 2x's will come out as a single 2x. And then we'll have 15th root of 2x to the 8th in parentheses. Oops. Okay, we'll do the last two problems on the next video.